It's my very great pleasure to welcome you all to the first annual David K. Backus Memorial Lecture in honor of our much loved and deeply missed colleague. This lecture is our way of honoring the memory of Dave in a way that seems appropriate to the person that he was, by engaging in a thoughtful academic discussion. And it gives us a chance to celebrate annually an important scholar and a life well lived. This lecture has been endowed by generous contributions from many of the people in this audience, by his family, his friends, his colleagues, students, and people who he touched in the many different roles that he played at the school. It is now sufficiently well endowed that this is guaranteed to be an ongoing institution at the Stern School of Business. But we have aspirations to do more. And so if you want to add to this legacy by giving a gift, please do consider it. Many people have had a lot to say about what a special friend, colleague, and scholar Dave was. And we have mourned his loss, the loss of his special grace. But today is a day to celebrate Dave by hearing from a speaker who is a great scholar, but also embodies many of the values that endear us to Dave. There is no more appropriate person to be the inaugural speaker for the Backus Lecture than Tom Sargent, for many reasons. Dave was instrumental in inducing Tom to come and hang his shingle at New York University, and they were good friends. But I want to talk about two characteristics that Dave and Tom have in common as individuals, one personal and one intellectual. On the personal side, I always deeply admired Dave for his love of life. Dave loved his life. And he was always an enthusiast, and he had a special enthusiasm for his students, an infectious enthusiasm, particularly about graduate students. Similarly, I think there's no group of professional colleagues that Tom Sargent values more than his graduate students. I greatly admire both of them for their genuine affection for students and the joy they take in mentoring them. And I had the great good fortune to experience that firsthand as a young graduate student at Penn when Tom, a newly arrived assistant professor, took an interest in me and what I was working on. On the intellectual side, Dave and Tom have in common that they both placed great value on clear thinking. Both have been role models for me, and Dave was my frequent tutor in this respect. When Tom won the Nobel Prize for Economics, I was chatting with Dave and I said Tom deserved a gallery of his own in the Museum of Clear Ideas, a reference to a book that we both liked very much. And Dave suggested that we write about that, and so we did. We produced an op-ed about Tom and Chris's prize called Clear Thinking About Economics. With that lengthy preamble, it's my pleasure to introduce Tom Sargent. His impressive achievements are well known, and they don't need rehearsing by me. That leaves us more time for us to savor some more of his clear thinking. The lecture will end promptly at 6 p.m., and there will be reception in a different location in the Gardner Commons on the first floor. It's my great pleasure to present Tom Sargent.
Okay, so the whole talk is on this slide, and you'll see why. So I'm going to talk about ideas that Dave contributed to and created, and that he admired. So the talk is, I apologize for this, I switched titles. It was originally 3 martingales and more, and now it's going to be risk aversion or mistaken beliefs, and those are the same thing. So here's a table. That's everything. So one column, probability density. So for me, a model is a probability density over a sequence, period. There's going to be a likelihood ratio relative to one model, which I'll tell you about. And it's going to be what this describes. The first thing is the econometric model. That's also what finance guys call the physical measure. Some people call it the truth. I'm not going to call it that. It's the econometrician's model. The second thing is risk neutral, and there's a likelihood ratio, M, and it's a likelihood ratio that you multiply the econometric model by that, and you get this other distribution. That's called the risk neutral measure, and what that characterizes is prices of risk. It characterizes risk aversion, prices of risk. The third is mistakes, either stupid or for some reason mistaken people. And there's another likelihood ratio, MW, relative to what? The econometrician's model. And that's going to be experts' forecasts. And the last thing is dubious agents, econometricians, who have estimated a model but doubt it. And what that is going to be, it's going to be a likelihood ratio that belongs to a set of likelihood ratios, and that's going to characterize specification doubts. And each one of those things is going to be an M, and if you do a little calculation, that M is a random variable. It's non-negative and has mean 1. And I'm going to pick out different ones by setting that B equal to 0. That's the econometrician's model. Lambda, that's risk aversion. Or W, that's mistakes. Or other things. Dave loved young researchers. And he learned from them, and he inspired them. So today, there's going to be a set of researchers whose work I'm going to mention, and they all have connections to Dave and NYU. Yarda, Anmol, a former student, and they have a paper which I could have featured today, and I'm not going to for a certain reason, but it's closely connected. There's Timothy Christensen, one of our colleagues, a young kid, and there's Balance, I can't say his last name, and I'm going to feature him. And part of what I'm going to tell you is some outcome of some suggestions he got from Dave. So that's where I'm going. He also liked middle-aged researchers. They're going to appear today. Monica Piazzesi, Jessica Wachter, Amir Yaron, he's going to appear, Stan Zinn, and Lars Hansen. So all these guys are going to appear. Okay, so here we go. Rational expectations. It's widely spread in macroeconomics, applied economics, game theory. It's the leading thing. And it was controversial in the 70s. It stopped being controversial. There's a 1970s, 80s informal justification for rational expectations, which I'm going to challenge. So the justification was, and this was hard work, least squares learning eventually converges to rational expectations equilibrium. Actually, self-confirming equilibrium, particular type. But now I'm challenging. That depends on assumption that agents know the correct functional form. Those learning theorems depend on that. There's some stuff hardwired. The proof techniques are beautiful. But in systems with long intertemporal dependencies, the rates of convergence are slow. And that leaves room for a gap. And it leaves smart people like Lars Hansen, who are good econometricians, to doubt their model. And anybody who's fit a model, worked their butt off to fit a model, doubts it at the end. Okay. But rational expectations equilibrium concept is the agents inside don't doubt their model. And rational expectations is a kind of communism. The agents inside the model, all the agents inside the model, the econometrician, and God all share the same model. So we're going to challenge that. So I'm going to start with good econometricians, and we're going to build up to agents who behave like good econometricians. And actually, if you go back and read Muth's paper, that's what he said. So good econometricians, and there's a number in this room, what do they have? They only have limited data, And they confess they have only hunches about functional forms. After their best econometrics, they fear that their models are incorrect. So there's Oliver Cromwell's rule. Think it is possible that you might be mistaken. So we're going to make agents who are like good econometricians eventually. That's where we're heading. Eventually. The second half of the talk. Following Ballant's work and Anmal and Yarda's work. So they have a good model. They have a parametric model that they've estimated from limited data. They know that. They acknowledge that other specifications fit nearly as well. There might be other parameter values. Go down the list. There might be other functional forms. There might be other nonlinearities and history dependencies. And add to the other equilibrium concepts, a whole bunch of things, a whole bunch of mistakes. So the question is, what should a decision maker do when he or she is informed by an econometrician who presents a model that he says is good and then reveals these doubts? That's where we're going. And that's a first-class problem that preoccupied people like Wald and Leo Hurwitz, and a number of other people, and Lars Hansen. So that's where we're going. Okay, so here we go. Set the stage. We're going to be in rational expectations land for a while, because most of finance is rational expectations. And when we do non-orthodox finance, we're going to leave rational expectations. But so here's the deal. There's the econometricians and the agents shared model. I'm not using truth. And this, I'm making this really simple. So an expression Dave liked was a little knowledge of log normal distributions goes a long way. And that's his talk. So there's going to be a state variable x, and it's a linear function of last period's x. It's a vector, plus a volatility matrix and a Gaussian random variable. And then there's going to be a y that's a function of the x and the noise, standard. This is simpler than first-year macro guys do here. Epsilon is going to be normal 0 I. RT is going to be something beloved to Dave. It's going to be the short-term interest rate, and it's going to be a function of the state. So the short-term rate is going to be some vector r times a state x. So this system is going to govern the dynamics of interest rates. It's going to shove them around. And the last thing is dt is some payoff. It's also a constant function of the state. That's the model. Okay, so what do we want? We want a price at t of a claim to random payout streams dt plus j. That's what we want. We want to price assets. And that's what Janet Yellen wants. She wants this theory. Janet Yellen's going to come back into this. And she, by the way, she's using a version of this theory. Okay, so I'm going to show you several versions of this theory. The simple version, that was the pre-Backus theory. And this is in which Dave knew well and respected well. It's rational expectations with risk-neutral representative investor. This goes back to Hicks, John R. Hicks, the expectations theory of the term structure. And Robert Shiller's principal scientific contributions, his early ones, are all based on this model. So the first model is that stock price P, X of minus RT, that's a discount factor. So the discount, the price today is the expectation of the dividend you get tomorrow and the price tomorrow. And it's just a pure expectation. There's no risk aversion at all. And what ET is taken with respect to the econometrician's model and the agent's model, and we're in a communist rational expectations world, there's no difference of it. You with me? And then you can do a little algebra and you can solve for PT as an exact function of the state. So that's a theory of stock prices. That's Shiller's model. He brought it to the data and it bombed. He got famous for that. He bombed. And so he said there's something wrong with that model. And a loose thing, Shiller's is the rest of his career he's been trying to figure out, well, what is it? Why did it bomb? Okay, the expectations theory of the term structure, it's the same thing. So if you look at the bottom, I'm going to use this. PT of 1 is the price of a one-period pure discount bond. It's the short rate in Bloomberg. PT n plus 1, that's the price of an n plus 1 period pure discount bond, a strip. That's what Bloomberg reports. So the above lines imply that the bottom lines satisfy those equations, and you can solve them. You can get the term structure as a function of the state. So when the state moves around, the term structure wiggles. That's the whole thing. And the whole thing that Schiller was an expert on, an earlier advocate of these, is the so-called rational expectations restrictions. The restrictions that Schiller is investigating all come from the cross-equation restrictions that that equation imposes. Stay with me? Okay. So here's the deal. Rational expectations with risk-neutral represent investor. Here's the deal for finance. It works pretty well for conditional means, and it works a lot less well for conditional variances. And that's the start of Schiller. There's a bunch of volatility puzzles. Things that are more volatile than this theory predicts. So those volatility puzzles are going to be the origin of some things we're going to talk about. So, so the glass is half full and half empty. So, and by the way, I don't want to offend anybody here. Central banks often use a version of the expectations theory of the term structure as their first cut at the data, their first reading. They're also going to use some modifications we're just going to talk about. Okay, so this is Dave. Wouldn't it be nice if we could make the theory apply even if investors are risk averse? They weren't there, they were risk neutral. They cared about risk. So they don't like variance. And the hunch is the model has a hard time explaining variances of stuff. Maybe people don't like variance and they do something to put in even more. I don't know, that's the hunch. So if they were risk averse, or if agents didn't have rational expectations, and the same equations, so wouldn't it, but you could continue to use the same formulas or things that reminded you so much of the same formulas that they were the same. So this is ask and it shall be given. And then Dave would say, if you don't ask too much. Okay, so here's the deal. So I'm going to let M, okay, so this is going to appear several times. So I'm going to let M be a likelihood ratio of a conditional density. And so this is like an exercise for Debrage. That thing is a non-negative random variable with mean 1. That defines it as a likelihood ratio. That means if I take a density and multiply by that, it's still a density. Okay. So what it's going to do is if I take that original density that I had in this model, normal 0, I, and I multiply by that likelihood ratio, and notice there's a lambda. It appears there. That top one is one of Dave's favorite formulas. He called it Ito's law, Ito's formula. It's not. It is. Okay. So it distorts, it changes the density, the mean, from 0 to minus lambda xt. It shifts the mean. That's what it does. It twists the mean. That's what it does. So, and in particular, it's going to turn out that covariances, Lars Hansen says, Dave loved this, that asset pricing is all about covariances, everything. So it's going to turn out covariances of returns with M are going to affect mean returns. That's all of asset pricing. Okay, so we're going to activate this M, and we're going to use it to try to affect mean returns and see what happens. That's the research program. That's the whole deal. Now, what is M? Okay, so the standard finance, undergraduate finance, or souped-up version of graduate finance. Oh, and here's something. Okay, so I see a bunch of young people, and they're saying, why aren't you doing this in continuous time like modern guys do? And so you know why. Dave hated continuous time. And he made you translate everything into discrete time, and I did it. Okay, so this likelihood ratio, the first one, the likelihood ratio expresses risk aversion. Lambda t is the price the representative agent, who's now risk averse, he charges for bearing exposure to this epsilon shock. So if there's that shock, if I got to bear an asset that has this macro risk, epsilon, you're going to have to compensate me by giving me a higher mean return. That's the deal. Okay. Okay, so here's post-Shiller asset pricing. There's the first one is I'm attributing to Lucas and Hansen. I'm using exactly the same formula, except I snuck an M in there. That's a likelihood ratio. So all it does is it twists the measure with respect to I'm taking the distribution. The same formula holds. Second one, that's Backus-Zinn. There's other co-authors, but I'm making them. Backus-Zinn, that's their term structure. It's exactly the same as Shiller's, except there's an M in there now. So that's going to absorb risk prices. So ask and it shall be given, and it worked this time. Okay, so here's the deal. There's going to be, the way this all works, the mathematics of this works, there's so-called risk-neutral dynamics. That's jargon from finance. So the idea, the original dynamics for the econometrician's model were that C lambda wasn't there. And all that's going to happen now is there's going to be a conditional mean shift that depends on that lambda. That shift the mean of the shocks, and C is the volatility. Notice, if you're a person that says, I don't like random models, I like only deterministic models, forget it. Because if C's not there, none of this goes. Okay, so the risk-neutral dynamics, I just said that. So with dependence of lambda t on xt, this is key. Dependence of lambda t on xt, that modifies the dynamics asserted by the econometrician's model. So there's a gap between the so-called risk-neutral model and the econometrician's model, or the physical model. And lambda t measures, so if we could measure this gap from asset prices, we could back out measures of risk aversion. When people have done that, they've gotten huge measures of risk aversion. Huge measures of risk aversion. So huge that they caused a tragedy. What did I say? They caused a tragedy. The first one is the Lucas model. It's the Lucas-Hansen model. It's actually the Lucas model. The father of this model is Robert Lucas. And the model is now an orphan because he abandoned it. He will not accept this model as a valid measure of risk aversion. Okay, so now you could do the following. I've just rewritten things. These are exactly the same formulas. This is seek and ye shall find. It's exactly the same. I even got the M out of there, and I put an E twiddle there. And that's just the twiddle is an expectation with respect to a distorted distribution. Okay, so we're going to come back to that. Okay. Okay, so now, so there's a huge amount of very productive work on this, and it's controversial. It's so controversial because you can back out measures of risk aversion, and a lot of people have the same reaction as Lucas. I don't believe it, so I'm going to abandon that model. Okay, so that's going to lead us. So what smart people like, two people Dave loved, Monica Piazzesi and Martin Schneider, they just completely cut off the link between macro and finance, and they just posited an arbitrary stochastic discount factor that's not linked at all to anything in the real economy. And they basically said, I don't care that I can't help Ben Bernanke or Janet Yellen. I'm not going to connect this to anything they care about, and I'm just going to fit affine term structure models. That's the way they went. It's a respectable way, but there's a huge amount of finance about that. Okay, so there's going to be another likelihood ratio that we're going to put on the table now. So here we go. And you know, I must say, it's like this is going into nefarious territory that Dave would. I could see Dave saying, "What are you doing?" So the thing is, we're going into mistaken beliefs. And for a long time, that's been a refuge for scoundrels. And it's the refuge goes like this. This Backus Zinn, rational expectations, asset pricing, and econometrics, that's mathematically difficult. I'm having a tough time with it. So people can't really do that. People aren't smart enough to do that, so they're doing something else. Okay, that's not where we're going. We're going to go in a different direction. People are more sophisticated, we're going to see, and they're going to have to do more math. When you leave rational expectations and you want to do it right, Laura's sitting here. You're going to have to do more math. Okay, so we're going to see that. Okay, but if you're a graduate student, don't leave yet, because the tools that Yarda taught you, you're going to be able to do some stuff. Okay, so here's the deal. So there's going to be another likelihood ratio. It's going to be mistaken beliefs. Now, anytime I say mistake, it's relative to some criterion. So it's mistaken relative to the econometrician's model. So this likelihood ratio M, there's going to be mistaken beliefs. I'm just going to reinterpret M. That lambda doesn't represent risk aversion. It's just the guys they're just using, they don't, they have the, maybe they just don't have the econometrician's model. They have those other dynamics, and they screwed up when they did econometrics. That could be. That's an interpretation of lambda, and this is an insight of somebody else, Backus, like Tallerini, and Piazzesi and Schneider. The idea is everything we could do with those risk aversion parameters, we could do with distorted beliefs. Observationally equivalent. There's a humongous identification problem. You cannot tell the difference. Okay, now, McFadden. Okay, beautiful. McFadden and Don Brown and Rosa Matzkin, it's a beautiful discussion about what you can infer from excess demand curves and whether they were identified. And McFadden has this beautiful discussion. It's this slide. Well, okay, lambda can be interpreted as either a price of risk, representing this agent's risk aversion, or representing something about a mistake in the head of the agent. So to distinguish this, we're going to need more information than Backus and Zinn or Lars Hansen use in a typical study, or more theory. That's going to be Hansen and Ballant. Or in a slightly related context, Anmol Bandari and Yarda. Or both. And that's going to be Anmol Bandari and Yarda and Ballant. Zoke. So I'm going to show you Zoke's application. So he's going to have both more theory and more data. So what are the data on? And by the way, a lot of this stuff was done at a place Dave loved, Carnegie. Because why did he love it? Because Stan was there. Okay, and it was done early because the guys who were starting rational expectations, they were studying forecast expectations. Modigliani and Simon and John Muth, they were looking at forecasts and they were studying their biases. That's where they started. Okay, so here's the deal. Piazzesi, Salamao, and Schneider have this paper, and here's what they do. Their idea is this: the representative agent is risk averse, and it has risk prices lambda star. So they're risk averse, okay. But the representative agent also has twisted beliefs relative to rational expectations, and the twisted beliefs are they get a star for this. The twisted beliefs are W star. So they have twisted or biased dynamics relative to the econometrician's model. Okay, so their idea is, that's their theory, and their idea is that professional forecasters, and there's lots of them, maybe some have made contributions to this thing. They're the ones in nice suits. They make money forecasting. Their forecasts, they posit, use the twisted beliefs and not to answer survey questions. They use twisted beliefs. They use their predictions are systematically biased relative to the econometricians. So that's their theory. More information. And they're going to take data on those. So here's the program. They're going to take data on these. Yeah, here's their strategy. They're going to use data on the state to estimate the econometrician's model. These guys are first-class econometricians. They're going to estimate that, step one. So they estimate A and C. Now they're going to take the forecasts, and they're going to project the forecast on the same axis. And they're going to interpret A star as a belief distortion. And then the third bullet form, if they have the gap between those, they can back out the W distortion. They can actually back this out, this W. And then the last thing is they're going to reinterpret what the rational expectations, Backus and Zinn, would estimate as lambda, because Backus and Zinn only have rational expectations. They're going to reinterpret that lambda as being actual lambda star plus W star. And where the prices of risk that are coming out of this are actually going to be much smaller than, and Lucas is going to like them better. Well, he's going to like that part better. Because the agents are using biased forecasts. So Piazzesi and Schneider, this is all identified and fit because they brought in more data. Okay, so now here's the question. So the punchline, I just told you this. Smaller risk prices, that's a victory. And they get patterns of these conditional mean distortions. They tell you some really interesting things in that paper about those conditional mean distortions, about the mistakes that these forecasters make. They make systematic forecasts in the way the dynamics are moving, about interest rates and inflation are moving. It's really worthwhile studying. Okay. So now, so there's some details about, they have a very, very shrewd econometric specification. I'll just say that. There's the variables. Okay. So they have some successes. They have some big-time successes, in my view. When I read that paper, I said, I wish I'd written that paper. So their successes is, first, W star is not 0. So they estimate W star. The discrepancy between those two measures, they don't impose it, they estimate it, and it's not 0. And in particular, they characterize it. The experts think the level and the slope of the yield curve is much more persistent than the econometrician estimates. Do you think Janet Yellen cares about that? Just read the minutes. No, don't read the minutes. Just read the announcements. Okay, so another thing that's going to happen is subjective risk prices are going to vary a lot less than the lambda x estimated by the rational expectations econometrics. So these are really rich findings in this kind of post-Backus Zinn. Okay, so now there's going to be a question that appears. Why are beliefs distorted? Piazzesi and Schneider's model is a first-class model. So they offer no explanation. They just are. They provide evidence that they are, and then they run with that. And that's a first-class way of doing things. It's also a first-class question to ask, well, why might they be distorted? And they have no explanation. They could be mistakes. They could be ignorance of good econometrics. Then you could also ask, well, how big are the distortions? That's a natural thing to ask. Statistically, how big? And if you're an econometrician, you're going to form likelihood ratios and start asking that. Okay, so why are beliefs good? So now we're going to get into, that's where we're going. So now we're going to go, by the way, now we're in the last two rows. We're in actually the last, okay, the talk, row 1 we're done, row 2 we're done, row 3 we're done with Piat. Now we're on row 4. Okay, doubts. So Lars Hansen has this quote from some French philosopher in French that says doubts are natural or something, uncomfortable but natural. But, so what we're going to have is so here's the deal. We're going to have a dubious investor. And, okay. So just truth, Leo Hurwitz probably would like this. Abram Wall would like this. Chris Sims hates it. Just going to tell you this. So we're going to have a dubious investor. And what he's going to do is he's going to share the econometrician's model, and he's going to doubt it, but he's going to doubt it. So this is Lars. So what he's going to do, so he's going to evaluate, so he's going to, you have a conversation with him or her, and they're going to say, yeah, that's my model, it's my best shot. Do you think there's other models that fit nearly as well that are, yeah. Why didn't you write down those models? I don't have time, or I can't. I can't solve them. So this is going to. So this, but do you care about him? Do you feel bad about that your model? He says, yeah. So what this agent's going to do, he wants to evaluate payoffs under a vast set of alternative specifications near his model, which equals the econometricians. So he wants to evaluate. Asset pricing is all about computing conditional covariances. He wants to compute those for other distributions. How many? A continuum. Not even countable. Continuum. So now he wants valuations that are good enough for any of these models in this set. So how's he going to do that? He's going to go to Abram Wald and Leo Hurwitz. He's going to calculate a bound on values. He's going to construct a lower bound on values. And then he's going to use that lower bound, not because he's paranoid, but because he wants a lower bound. Because he knows if he's going to protect himself against specification mistakes. That's the deal. This is controversial. And I could say it's natural for an econometrician. And you could say, oh, yeah? Call up Chris Sims. But now, my defense. Now, this loops back to Dave, my defense. Which Chris Sims? The young Chris Sims or the old Chris Sims? Because the young Chris Sims was very much into specification analysis, misspecified. It wasn't a Bayesian. Okay. The old Chris Sims is a Bayesian. So, okay. So, anyway, this is my problem. Okay. So now we're just going to do. This is first year macro. YARDA. We're going to do valuation under the econometrician's model, just as a warm up, and that's going to be unique. There's going to be one value function. And that's getting us ready for Balint and YARDA and Lars Hansen and more. Because now we want, okay, if you have sets of models, you're going to have sets of values. Okay, so that's a Bellman equation, and I'm going to use log throughout here. I'm just going to use log preferences. So C is the log of consumption. So this is the working model of actually Lucas's, one of his great papers on the cost of business cycles, and Lars Hansen's paper on consumption charge spec. So we know how to solve that. Okay, so first we're going to start with Lars Hansen's dubious agent. Dubious about Lars Hansen's model. So he's going to share the econometrician's model, and what that means is a tuple of matrices, A, B, C, D, and G. So he's estimated those, but he doubts them. So what he does is he expresses those doubts by using a continuum of likelihood ratios. Okay, now Dave loved this term, I think partly because it strikes terror. Two reasons. Because a big player in this was Veridon at NYU Math, and another thing is it strikes terror in the heart of economists. He's going to use to form discounted entropy ball of size eta around the econometrician's model. So what entropy is it's an expected log likelihood ratio. And it's used by, one of the reasons it was invented by my father-in-law's algebra teacher, Kuhlbach, to do information theory. So he wants valuations that are good enough for every model in that entropy ball. So what Lucas told you is, wait a minute, every different model, cross-equation restrictions, the Lucas critique, every different model, you're going to have a different valuation. And this guy says, yeah, I'm going to have a set of valuations, and I want a bound on them. So he's going to construct a lower bound on those values, and then what he's going to do, he's also going to construct a worst-case model that attains that bound. He's going to construct a bound because he's interested in protecting himself, and he's going to construct a lower bound on values. Okay, so why discounted entropy? So Lars Hansen discounts entropy. Okay, and there, you could say there's something sneaky or really insightful about that, because Verdon didn't, and statisticians don't. So they don't discount it. So why discount? Why do undiscounted entropy? Why do we discount entropy? And the reason is there's a Cornell literature, there's a Bloom and Easley literature, and there's a literature on the Blackwell-Dubin's theorem. So the reason is undiscounted entropy excludes too many models that are rarely difficult to learn about with finite data. So undiscounted entropy over infinite sequences, that's what I said, and it's because they all share laws of large numbers. Undiscounted entropy includes only models that, okay, anyway, I said it. So that's where we're going to do it. Okay, so now this is first year macro. So this is Hansen's agent sequence problem. And it's a bunch of math here, but the deal is, so here's the deal. There's going to be, this is your helper. Or in my case, your wife. Okay, so like, are you sure you have the right model? So this helper is going to, you want to form expected utility, and there's my martingale. M is a martingale. You want to form expected utility over a whole set of models. Those are going to be indexed by M. And that M there, that follows this law, and that's a multiplicative martingale. That's a multiplicative martingale. And so there's going to be a minimizing agent who's trying to find the expectation, the mathematical expectations that finds the lower value of this. That's what he or she's going to do. So that's a problem, okay? So that's what Lars is going to use to construct a bound. And this is my discounted entropy ball. That's a representation of entropy. Peter Whittle or Verdon would not have that beta in there. And it would have an effect, actually a minor effect, if beta is close to 1. But it would have an effect. Okay. So, okay. So entropy. Dave loved entropy. Here's a formula. Looks like a terrible thing to compute. It just turns out to be WT prime times WT 1/2. That formula is all over Verdon's work in large deviations theory, which Dave loved. Okay, so that's going to simplify Lars's Bellman equation to look like this. Now instead of that M, it's out of there, and it's just an expectation with respect to distorted dynamics. This is beautiful, because this is this would not make Yarda's homework list, because it's too easy. This is just a simple, very simple linear quadratic dynamic programming problem, where you just choose this, and you put a Lagrange multiplier here, and you're done. And you know, Chase and Spencer can have programmed us up in 5 minutes. Okay, so here's the deal. So the idea is, that's your model. And then this is an abstraction. You're surrounding this with a continuum of models. And there's a zillion models in there. And eta is going to be the size of the entropy ball. Okay, that's it. Okay. So now, and Lars has done that, and it leads to some interesting work that has some partial successes. So now Ballant, who's a graduate student at NYU, so like my colleagues know this. If you're a teacher at NYU, you're not really the teacher. The 4th and 5th year students they're coming in and say, like, have you heard of this? Okay, so here, this is Ballant. And Dave loved this. Okay, so, and he saw an early version of this work and asked it. So here's Zokay's dubious agent. And it's going to start with this ball. He's going to share the econometrician's model. He's going to express doubts just like that, but he's going to insist that some of the martingales inside that ball represent a particular parametric model that he's worried about. There's the econometrician's model, and he's going to say there's a particular model I'm worried about. And he's going to get this thing he's worried about from a good friend of Dave Backus, Amir Yaron. So he wants a particular parametric model to be included in this ball. Most of the models in this thing are nonlinear. They have big history dependence. You know. Okay, so what he's going to do is he's going to be concerned about a particular other parametric model. And the way he's going to do that is he's going to represent this model in a really clever way. As a quadratic form, he's going to say that the time t contribution to entropy of that model is going to be given by a quadratic form of the state. And what he's going to do, he's going to redo Lars Hansen. Actually, some of this work is joint with Lars and Ballant. He's going to redo Lars Hansen, and he's going to replace the entropy constraint that Lars had with this entropy constraint. If you do a little thinking, this is going to make sure that that model is included in the ball. So what model does he want? Now, this is a Dave Backus term. Yaron's bazooka. Okay, so there's a particular kind of model that this guy might be concerned about, and this is long-run risk. So here's the idea. Banzhal and Yaron built on something that Stan Zinn did. What they showed is that if you mix long-run risks with Epstein-Zinn preferences, you get something that's really powerful. That's why he called it a bazooka, I think. I don't know why. Okay, so the idea is long-run risk is really hard to detect statistically and estimate. It's very hard to tell. And if you're a first year, it's because it's all about the spectral density really close to zero, and you have to wait a long time for that. So it's very hard to learn about. Nobody disputes that. And by the way, the evil agent, the minimizing agent, knows that. And then the second thing is the Epstein-Zinn or the dubious agent, either one, they really hate long-run risk. Okay, so Yaron's bazookas, combine them and see what happens. And then there's a footnote, and Dave liked this. There are conditions under which Epstein-Zinn value functions are indirect utility functions of a dubious agent, which is beautiful. There's a reinterpretation of Epstein-Zinn. Okay, so all this sets the stage for big risk prices. Okay, so this is the deal. So now, what is Ballant after? The big picture. Ballant's after, he's going to have a theory of distortions which have a chance of matching Piazzesi and Schneider's data. That's where he's going. He's building a theory, decision theory, about how people form distorted expectations, and he's going to use those. So he does some math, and he can recover everything he wants. So the way this is going to surface in a beautiful picture in his paper, I just say recommend this. What it's going to do is it's going to take the entropy ball and it's going to twist it. It's going to twist the entropy ball. It's going to twist the shape. And what that means is after it twists shape, it's going to affect what the worst case model is. And it's going to affect it in a really interesting way that's going to give him a shot at matching some of Piazzesi and Schneider's data. Okay. So in particular, he's built in there, so when he does this analysis, follows Yaron, does long-run risk. By the way, you know who's worried about long-run risk? He doesn't put it this way. It's Larry Summers. Secular stagnation. That's what all about it is. And he's trying to scare you about it. But there's no question there's risk there. So maybe you should. So Stan would be really scared about that, because it might be there. Okay, so what this is going to do is this particular thing is going to make the if you stare at this is beautiful. That's an expectation of a present value, so it has time t components, but the restriction is only on the present value. So there's trade-offs. But the time t contribution to that sum increases and decreases depending on the state. So there's times in which a distortion to the conditional mean is cheaper in terms of entropy, and there's times when it's more expensive. And Balint built on that insight. Okay, so in particular, it sets the stage for state-dependent means distortions in the worst-case model. So Balint, probably looking at this math, he says, wow, that gives me a shot at matching Piazzesi and Schneider, because that's what they found. That's what they're living off of. Those lambdas are functions of x. So in particular, this is stuff Sidney and other people have made huge contributions to. This can ignite in a different way than other people have said, counter-cyclical market prices of uncertainty. Okay, so here's the deal. So this is Balint's problem. Turns out this is a first-year macro problem too. You know, you just reinterpret the control as a distortion. So, and I can see some first-year macro problems telling me something hard. Okay, so this worst-case mean distortion is going to look like that. And then Balint can actually get, theoretically, he gets a theory of what that thing is. So you remember I said Piazzesi and Schneider, why are things distorted? They just are. He's going to tell you, oh, these guys are smart. These guys are smarter than a rational expectations guy. They're like Lars Hansen. They doubt their model, and they're doing something to protect themselves. That's where he's going. Okay, so I'm going to wrap up in a little bit. Okay, so this is now Dave would have loved this picture, and Chris Sims wouldn't, because Dave Backus liked autocorrelation functions, and Chris said you shouldn't be looking at those. Well, we're looking at them. Okay, so what the heavy line, that's the autocorrelation function. That's consumption. That's a cross correlation. That's it. The heavy line are what comes from the econometrician's model. Okay, that's what they are. The green line, that's estimated. That's estimated just taking the autocorrelations, Box and Jenkins. Just compute the autocorrelations. No model. So there's a little model. No model. And the green stuff, the fuzzy green stuff you can see, those are confidence coverage intervals. And what you'll see is, look at this one in particular. That's consumption growth. And that's why people like Lars Hansen might be a little skeptical of Larry Summers. Because Larry Summers says, I know there's secular stagnation. And from that, maybe. But that coverage interval, there's lots of stuff in there. But if you look at that, a fear of long-run risk. So long-run risk is that thing doesn't go to zero like the model builds in. It goes and stays close to zero, but it's for a long, long time. The Epstein-Zinn guy hates that. Okay, so it's kind of plausible to have this long-run fear of long-run risk in this model. This is from Balint's paper. Okay, so then here's a Dave-like picture. This is the U.S. term structure. So it has some patterns. So this is pattern recognition. Those are recognized patterns. The nominal yield curve usually slopes up. The long minus the short yield spread narrows before recessions, and it widens after. People make money predicting on that. Consequently, the slope of the yield curve helps predict aggregate inputs and outputs. The long-short yields are almost equally volatile. Dave was interested in this. That's called the Shiller puzzle. And to solve the Shiller puzzle, risk prices or something observationally equivalent to them have to depend on volatile state variables. That's our lambda t or w depending on x. That's what you're going to have to do to crack that. I'm just reading from Balint's paper. Okay, so challenges and responses. So this is another table. So actually shows you the way progress has been made in this. What do you want to get if you have a theory of the term structure? Average slope of the yield curve. You want slopes near recessions and before and after, and you want volatile long-term yields. Lucas model, as beautiful it is, it's a failure in all of them. Epstein-Zinn with long-run risk, that's Piazzesi and Schneider, Hansen and somebody. Average slope, probably not. Slopes near the yield curve, near recessions, yeah, you can get that. Volatile long yield, no, it's a bust. Okay, Piazzesi and Schneider, this is why this paper bears. Average slope, they build it in. Slopes near the recession, they build it in. Well, you could say build it in. It's like those forecasts of those guys really are biased, and the features of those cause this. And then volatile line, they get that. So Ballant, he gets a bigger yes in the first one. He gets the yes in all of them. And he gets interpretations. He's going to get some additional and changed interpretations. So he's not just reproducing what they did. Okay, and he has interpretations that Janet Yellen's going to care about. So those are challenges. So here's the forces at play. Affine risk prices with persistent growth, consumption growth can nail the second column. That's what's going on here. And the third column requires state-dependent prices of risk. And you know, so I view this work by Ballant and Anmal and Yarda as essential to macro because it was the failure to account for these that caused Lucas to orphan his model. And when he orphaned his model, he cut macro off from being able to give Janet Yellen any advice about, you know, the thing that Lucas fails is the new Keynesian IS curve. So this is a failure central to macroeconomic policy. Okay, so there's, okay, 3 martingales and more. I told you. Okay, so here's the motivation. Here's going to be Ballant's strategy. And this is a beautiful quote, which I wish I'd written. It's by Ballant. I'm going to read it. Because this is leaving rational expectations, but in a very respectful way. An appealing feature of robust control theory, that's what he's using, is that it lets us deviate from rational expectations, but still preserves a set of powerful cross-equation restrictions on decision-makers' beliefs. That's Tim Christensen. Consequently, estimation could proceed essentially as with rational expectations econometrics. The main difference is that now, key, restrictions through which we interpret the data emanate from the decision-maker's best response to a worst-case model, his worst-case model, instead of to the econometrician's model. That's the twisting. Okay, so this leads to various things. There's some math. Okay, so Ballant's empirical strategy. He has a very shrewd empirical strategy where he is going to estimate endogenously what that psi function is. He's going to estimate that endogenously by imposing the modified Backusian term structure cross-equation restrictions. He's going to back it out, and then he's going to use it to study. He's going to use it to study the distortions, the appearance distortions, and the predictions of forecasters. That's his machine. And as with applied work, he has some partial successes. I'm just going to end at that. So what are the insights of this model? He has a theory of belief distortions. He has a theory about which what the question the professional forecasters think they're really being asked. So they answer with their worst-case model because they hear it, tell me the forecasts that rationalize your decisions. I'm shading the econometrician's model when I'm doing the decisions. And he gives you a beautiful Verdon, actually Charles Newman, a great Courant person, a way of assessing how large the belief distortions are. And there he's going to use a different kind of entropy. So he does that. He tells you, are these big distortions or not? And he argues that they're small. So small distortions are going to give rise to these big things. And then he finally has, he has a, okay, I'll just say one thing. He has an interpretation of this WT. And what it is, it's a beautiful interpretation. It's not the market price of risk. It's the market price. It would vanish if the dubiousness vanished. If the doubts about the model vanished, this W would go to 0. So what the W is, it's not a risk price. It's a Knightian uncertainty price. And it's moving around. So when you say risk, it's not risk appetites. It's doubts about the model. And that's being shaped by his beautiful chi function. Okay. So if Dave were here, it's, sorry, okay, I'm just going to stop with 2 more slides. Okay. And I tell you why I admire this work by Ballant and Anmal and Yarda. So joint probability distributions of interest rates and macroeconomic shocks are important to macroeconomics. They govern our inferences about the cost of aggregate fluctuations, business cycles. They are the consumption Euler equations, called the New Keynesian IS curves. They're central to optimal taxation of both the Ramsey and Golosov kind. They're central to government debt management. They're central to central banks' quote-unquote expectations management strategies. And they're central to long-run risk and secular stagnation, and more. All these things are interconnected, and they're central to macro. And these young guys, helped by Dave, I think are making great progress. And if I were that type, I'd be jealous of them. So I just want to conclude with Dave Backus. So Dave Backus contributed immensely and graciously to what we know and how we can go about learning more. And rather than curse darkness, Dave lit candles.